Okay, this is 4.5a of geometry. We're going to start looking at isosceles triangles. So isosceles triangles are triangles that have two congruent sides. And those two congruent sides, we call it legs. So those red sides there, as you see, are the legs. The other side we call the base, and that's in green. And then the two purple angles that are attached to the base, those are our base angles. And the extra angle, the blue angle, is called our vertex angle. Okay, our isosceles triangle theorem says that if the two sides are congruent, then the base angles are congruent. And you can see that in the picture. If the two sides are congruent, the legs are congruent, then the base angles are congruent. Okay, it's really not a bad proof. So if we start with an isosceles triangle and we draw in some segment, XB, so that's the one that's going up and down here, and we choose that segment specifically so that it splits our vertex angle up at the top into two equal angles, so it bisects that top angle X, okay? We're trying to prove that our base angles are congruent down here. Well, by the definition of bisector, I can say that angle 1 is congruent to angle 2. Then by reflexive, I can say that XB is congruent to XB. So then I can say that the triangles are congruent by SAS. Then, once I've said that the triangles are congruent, I can say that a corresponding part is congruent by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, we also have the converse of the isosceles triangle theorem, which says if the base angles are congruent, then the legs are congruent. Okay, so let's try our got it problem. We're looking down at this picture here. It says, is angle WVS, so the one right there that's marked with the arc, congruent to angle S? So right now we've got this little triangle down there, WVS. These are congruent. That's congruent. So I got that the legs are congruent. So yes, WVS is congruent to angle S, and that is by the isosceles triangle theorem. Okay, then they want to know, is TR, this guy, congruent to TS and Y? So I should update my picture here. I just said that WVS is congruent to S, right? Well, it's also marked that angle R has one arc. So if I'm just looking at this big triangle, I have, well, that was pretty bad. This big triangle, I have that my base angles are congruent. So using the converse of the isosceles triangle theorem, I can say that the legs are congruent. So, yes, TR is congruent to TS by the converse of the isosceles triangle theorem. Remember, converse just means you switch the if and the then. So my isosceles triangle theorem says if the legs are congruent, then the base angles are congruent. And the converse is when I switch those. So if the angles are congruent, then the legs are congruent. Okay, here's another theorem. It's just theorem 4 or 5. So if I have that the legs are congruent, and I have that those top two angles are congruent. So I'm putting in a line that splits them so that they're equal. So it bisects that angle. Then CD, the up and down one, is the bisector, is perpendicular to the base. And it also, this point down here happens to be the midpoint. So AD is congruent to DB. Alrighty, so we're just going to use our got it problem here. Looking at this triangle. So suppose instead that angle A was 27. Okay, so maybe I'll just redraw it for us. Oh, that's kind of not the best drawing, but these are congruent. And this is 27 degrees. And I'm trying to find that guy, X. Okay, well, I know that these two legs are congruent, right? If I'm looking at the big triangle, I have legs that are congruent. So, using the isosceles triangle theorem, I know that my base angles are congruent. Right? So I know, and I'm just going to switch colors here, that guy is congruent to that guy. So over here is also 27 degrees. Then if I look at my big circle, so now I'm going to look at triangle ABC. I've got 27, 27, and these are congruent up here, so I've got x plus x, which is 2x. I know that inside of a triangle, they add up to 180, so I can set up an equation. 27 plus 27 plus 2x equals 180, and solve it. Here's another option. Looking at this picture, let me take, oh shoot, we'll leave those lines on there then. So if you think back to the theorem that we just looked at, 4, 5, I have the legs congruent, and I have these top two angles here congruent. Then I know that this is perpendicular. BD is perpendicular to AC. So that angle right there, sorry it's getting a little messy, is 90 degrees. Right? So another way I could do it is I know 90 plus 27 plus x needs to equal 180. Both going to get you the right answer, just two different ways we can do it. I'll do this one on the right here. 90 plus 27, I'm going to work up top here, gives me 117 plus x equals 180. And I subtract 117 from both sides, and I get x is equal to 63. There's your homework.